face that will be taught today afternoon. And at this point of time, I strongly suggest a few of the green belts here, right? Maybe one or two. So you can check whether you will be able to upgrade. If still possibility is there, you can upgrade because you have come up to this. And now updating the additional tools is not a tedious job for you. But maybe as the time goes, what will happen? You might again, forget some of the basics and then they have to be recaptured. But now you are in the right time. Maybe if needed, you can talk to Mr. Prabhakar and see whether you can be part of our next week discussion so that all that you gained can push your learning next week. Yes or no? So you can explore that, but you will definitely lose the chance if you don't reach to our members at the right time. Okay. So now again, tell me why control chart? Why control chart? If there is no control
No,
chart,
Monitor the
no,
performance.
where we are, actually, where we are, if we are in, suppose if you take the any corrections or if you take any mistake, that is, whatever performed or whatever it is produced, so is the right or wrong, but we have to cross verify the either manufacturing unit or production unit or what do you say, verification also.
so where are we right now? Nothing but baseline. Whether the projection of the baseline, see anything if you calculate by 100% audit, there is no doubt that is correct. Yes or no? But only when you take sample, you predict, it becomes an estimation. Your estimations should be close to the reality. All your estimation can be close to the reality only if the process is under the state of control. Process is under the state of control. If process is out of control, your CPCPK is great. It doesn't mean anything. It is like somebody not attending the class properly, not doing any of the assignments properly, but still scoring a good mark in the exam. If your son score, if your children score high marks without going to the school, without spending time on studies, what does it mean? Tell me.
Chasing a teacher.
We are
No, it is a
doubtful.
fault.
How come
It
he
is
can
a
score,
fault.
isn't it? So that is the scenario. If your control chart is out of control, still your CPCPK is great. So it becomes an essential requirement for a process to stay under control so that all your predictions can also be accurate. Otherwise, your predictions and all your estimations can be abruptly wrong. See, it is like a scenario. If somebody is not willing to listen to you, will it make sense you delivering a lecture? He's not listening to you, but you are still delivering a lecture. It is not going to make any impact. If somebody is not willing to listen and you keep on giving the advice, where is the advice going? It's going somewhere and it's not listening. So similarly, your process must listen to you. Your process should be under your control. Don't worry whether it is good or bad. It can be good, it can be bad, but it should obey you. It should under your control. If that control is established, improvement is definitely possible. And those who are targeting improvement without having enough control, they are giving good advices to a person who is not at all listening to you. All your improvement efforts will become a wasteful effort, yes or no? So, control chart can help you to understand whether your process is under your own control or not. We call it statistical control. If the process is under statistical control, it is ready for improvement. Your process is not under control. Still you are improving. You might see result, but unsustainable result. What is unsustainable result? By the time you do the experiment, yes, results will be promising. The moment you allow it to continue, the results will again fall down. What kind of result do you want? You want sustainable result or you want unsustainable result? Sustainable result. So, control chart, should indicate statistical control. You can plot control chart for your y variable also. You can plot control chart for your x variable also. Which is good?
Yes.
Very good. If you have gained control over X, don't stay there. Come to the X. Initially, we all look at the marks scored by our children. Yes or no? The moment your children started scoring above 90, then what will be your job? You should ensure they are continuing it, isn't it? They are studying daily, they are eating healthy, they are going to school. These are all X. So you must shift your focus from Y to X. That's an indication of your real experience, real maturity, your process knowledge, your product knowledge. All of them will reflect in by understanding what are you monitoring. If you go to a company, they are talking more about the why. What does it mean? They have a lot to learn. Yes or no?
Yes.
They have to understand their process. They're not talking about the input. They're only talking about output. They're only talking in terms of why. Some companies go to the extent of talking in terms of Z. You know what is talking in terms of Z? I need 500 crore revenue. They have not even come to the process. But some company, they really talk about why. But good companies, they not only talk about why, they also talk about X. So they will monitor the why over a control chart. After gaining enough control, they will switch their focus to X. All of you are with me? All right. So again, when you are plotting control chart selection depends on your data type. Your data broadly into two categories. You all know. What is one category? Continuous data. The other category, discrete data, or you can also call it attribute data. So you need to understand your situation. What is the variable I am trying to control? If I am monitoring my body weight is a continuous data. Right? My body weight is a continuous data. Similarly, if I am monitoring boiler temperature, it's a continuous data. If I want to monitor the number of parts that are rejected, it is an attribute data. Number of parts that are rejected every shift, isn't it? Number of parts that are rejected every shift is an attribute data. So there are two types of charts. Control chart for variables, nothing but control chart for continuous data. Another one is control chart for attributes. Control chart for variables, control chart for attributes. But in both control charts, you must understand the basic terminology. See, what are we trying to control in a control chart? We are trying to control the variation. We are trying to control the variation. Variation can be of two types. One is common cost variation. Another one is special cost variation. What is common cost variation? The way I have designed my process, certain variation is part of my process. That's how I designed it. Say, for example, we designed the program in such a way that all students can score above 80 marks. 80 to 100. If any of you score 80 to 100, we should be happy about your performance. Yes or no? Because we have designed it that way. So 80 to 100 is part and parcel of our process. Am I right? But if somebody scores in a single digit, it is an indication that something is really going wrong. Yes or no? If the variation is beyond the expected limit, it is known as special cost variation. If the variation is within the expected limit, it is known as common cost variation. Always the expected limits are, in control chart, the expected limits are control limits. All of you, do you know what is a control limit? Can one of you give me the definition of control limit? What is a control limit?
Where the value is lying within the limits.
See, there are different limits available in the Six Sigma
acceptable
language.
limits.
There is, I'll tell you,
Acceptable.
I'll now confuse you with so many limits. There is specification limit, there is control limit, there is confidence limit. Do you know the difference among all the three? There is specification limit. Who will give the specification limit?
It will customer.
Customer. So hereafter, don't use the word specification limit in other places. If it is decided by the customer, no formula, no logic, nothing. Customer has fixed it. Such limits are known as specification limit. Control limit is derived from the process data. Control limit is always derived from the process data, the history of data. If you have enough data, data itself will tell you the nature of your process. Your process has the nature to go up to this point. What is that point? Control limit. Your process always operate around a particular point. That point is nothing but process average. You all know what is process average, right? You collect some data, calculate average. That is the tendency of your process to produce more outputs around that. Yes or no?
Yes, yes.
Average, the other name for average is expected value. You can expect your output to appear closer to the average. Once you know the average, you can, with the same data, you can also calculate standard deviation. Am I right?
Yes, yes.
There are formulas for standard deviation. Square root of summation of x minus x bar, the whole square divided by n minus 1. You all have studied this in schools. You can use it now or you can ask Excel to do it. And use the formula to find out standard deviation. Once standard deviation is understood, average plus 3 times standard deviation will be upper control limit. Average minus 3 times standard deviation will be lower control limit. See here, I have taken my whiteboard.
Sir, one is specification limit, control limit, and third one is, sir,
Confidence limit. Confidence limit. See here, this is a process. Can you see a bell curve here?
yes.
Most of the biological data will exhibit bell curve. If I take all your weight is a biological data, isn't it?
Yes.
Similarly, your product also has biological data because the data is generated based on the nature of the process. Right? So, this is a kind of bell curve. And what is at the center? Average.
The mean.
And what percentage of the data will fall to the right side of the X bar?
50%.
50% right side,
50% left side.
That's it.
50% left side. And if you come here, almost the curve started approaching x-axis. But it will go up to infinity. Please note, RK was mentioning plus infinity and minus infinity. Okay, plus and minus. But you don't have to go up to infinity to understand, what's happening at the infinity. Infinity is something we can't reach. So don't go up to there. Just come up to a distance 3 standard deviation away from the center. This is your upper control limit. This is your lower. Do you understand? So formula for upper control limit is average. How much distance now? 3 standard deviation. Similarly, lower control limit formula is average minus 3 standard deviation. All of you, do you now have the definition for control limit? What is the definition for control limit? Center plus minus 3 standard deviation. Clear? Now, customer gives a specification. Now, all that needed to produce, quality products is your control limit should be inside the spec. Customer is drawing his limits here, upper spec and lower spec. Now, where are you seeing your control limit? Inside the spec or outside the spec?
Inside.
Inside the spec.
That
Between
means
LSL
that-
and USL.
Yeah, that means your process is capable. Majority of the parts produced by your process will be accepted by the customer. Am I right?
Yes, yes.
Yes.
Only a very, very small chance exists. You can see here. Very small. Am I right?
Yes.
Very, very small. Definitely no less than 1%. Statistically, it is found that 99.73% of your outputs will fall inside control limit. what percentage of the output will fall inside control limit?
1%.
99.73%. That is why it is always important to know where is your control limit. You can judge about 99.73% of your output. Clear?
Sir, I have a doubt. This is not related to the subject, but is a
Yeah.
like an interview question they asked me. Amitabh Bachchan height is somewhere 66.5 or
Okay.
65 centimeter. In
Hmm.
which side of the graph means which side of the normal curve he fall? So what will be the answer? At that time, I don't know that much about this.
Oh,
Yeah.
that was an easy question they asked. You should have
So
cracked
it
it.
be 3, maybe now it is x bar plus 3 sigma, can I
Okay.
see?
So
Right
Amitabh
side.
Bachchan, you know Amitabh Bachchan lives in India only, right?
Yes, yes.
Yeah, that much you know. In
Yes.
India, what is the average of an human being?
5.6 to 5.5 to 5.6 or 5.7.
What is the maximum height we can normally see?
5.6, sir.
No, 5.5 is average.
Ah,
Can't you see a person with 6.5 feet height?
rarely,
Rarely.
rarely,
And 4.5 also you can see.
rarely.
If you meet 100 people, how many people will be around 5.5?
Most of them.
10 people, 20 people, 30 people, most of them.
Yes.
Most of
Close
them.
to 70% of the people will be around 5.5 only,
Yeah.
right? This area is 70%. That means this area and this area. This will be 15, this will be 15. Do you get my point?
Yes.
Yeah, yeah.
15% means it will be like this.
Yes.
Lesser number of people. Now you see. Now you see the bell curve, right?
Yes.
100 people, when I distribute, it looks like a bell. Those of you who are around 5.5, they're all standing in the center. Those of you above the average, they have to stand, this
Yes.
region, right side. And those of you who are, not smaller in height, they are standing on the left. So where is your Amitabh Bachchan?
Yes,
In the
sir.
right.
In the right.
Right.
Amitabh is to the right side of the average human being in India.
Okay.
But the question is not diving deeper into statistics.
Okay. Yeah, yeah.
If I am in the panel, I will ask you whether Amitabh Bachchan is, beyond the control limit or within the control limit.
So beyond the control limit.
I'll tell you the country's average height is 5.5 and the country's standard deviation of the height is 0.25. Now you have to tell me whether Amitabh Bachchan is out beyond the control limit or within the control limit. So what is Amitabh Bachchan here now height? You said 6.5.
5.
6.5 is beyond upper control limit or within upper control limit. So how much is upper control limit here?
5.7.
6.5.
5.5 plus
2.5.
0.75.
5.75.
0.25. 0.75, right? 3 times standard deviation.
Yes, yes.
So 6.25 is your upper control limit. But where is Amitabh Bachchan?
6. It's 6 point beyond the control. Beyond the control.
That means 99.73% of the Indian population are inside 6.25 feet only. Inside 6.25 and left side is how much? 4.75. Do you understand?
Yes.
4.75 to 6.25 will be the height of human being in India. What is the percentage of my confidence here?
99.76.
99.
I am 99.73% confident that people found in India will be having a height between 4.7 feet and 6.25 feet. If I choose 1,000 people randomly, 997 people will be in this range only. Do you understand? Only 3 people, and Amitabh Bachchan is falling in that 3.
Yeah.
All right.
Yes, sir.
So This has to be.
Thank you very much, sir.
So, okay, good. So, Vivek sir, when is your session now?
Not, sir. Today I don't have any session.
Okay, you have just joined. So, by
I just wanted to know, be present and learn something.
I'm just talking to them about the control chart. Okay. So I want all of you here to understand how a control chart will look like, and I'll be focusing more on the basics so that, when you actually plot control chart, you will be able to interpret it very well. See, any control chart typically will look like this. There will be a center line, there will be an upper line, there will be a bottom line. So the center line is this, and this is an upper control limit, and this is a lower control limit. All right. We expect all our points to fall inside the control limits. There is nothing wrong in expecting all the points to fall inside the control limit, because how much chance is there for the points to fall inside control limit?
Maybe 1%.
Plus 99.73%. Just now I told you.
Yeah.
There is 99. Your process is designed. The nature of your process is to produce outputs within the control limits 99.73% of the time. If you produce 1000 parts, 997 parts should fall here only. That is the inherent nature of your process. Do you understand?
Yeah.
So hereafter, if you see, hereafter, if you see a control chart with all the points falling inside the control limit, you can understand your process is performing as per its design. You designed the process in such a manner, so that is happening. You should be happy about it, yes or no?
Yes.
But whatever variation right now you are seeing, this is inherent nature of the process, yes or no? You only designed it. So don't try to control it further. Accept to live with it. Yes or no? Agree, all of you?
Yes.
This is the nature of the process. You only designed it, and so it should be part and parcel of your life. Such variation is known as common cause variation. You eliminating the common cause cannot happen, in the current design of the process. Do you understand? Elimination of the common cause, cannot happen just like that. You may have to even change the fundamentals. Then only common cause variation you will be able to attack. Right now, the common cause variation, you cannot do anything, because the reason for common cause variation cannot be attributed. You can simply say that your process is designed so. All of you understand what is common cause variation? Right? The variation that is occurring because of the inherent nature of the process. You just cannot eliminate. But if points are falling here in this region, you can understand these are because of certain special reasons. The if a point is found outside the control limit, then the variation is classified as special cause variation. So there are two types of variation: common cause and special cause variation. And now please tell me, if I'll ask a simple question. If you are going to your office by bike, or if I ask all of you to go to a particular place from a common place, imagine all of you are in a common place. I want all of you to reach a destination by traveling by a bike. Do you think all of you will reach the destination at the same time?
No. No.
Some variation always, will come into play. So I see that, the people are reaching the place from 35 to 45 minutes. That means on an average, all of you reached the place by 40 minutes. Am I right?
Yes.
And the lower value is 35. Upper value is 45. That means the spread of the process is 10 minutes. Can you see that?
Yes.
This is the maximum time. This is the minimum time. Maximum is how much? 45. Minimum is how much? 35. The difference between maximum and minimum is known as range. Do you agree?
Yes. Yes.
And this range can always be equated to 6 sigma. That means what is there at the center? Your average. Yes or no?
Yes.
To the right side of the average, how much you have? 3 sigma. To the left side of the average, how much you have?
3.
360. So this becomes your upper control limit. This becomes your lower control limit. Now for your process, the average is understood. Upper control limit is understood. Lower control limit is understood. If I ask all of you to go to the same place one more time, again, more or less, all of you will reach the place in 35 to 45 minutes, isn't it? But certain person may reach earlier, certain person may take some more time, but overall, all of you will reach between 35 to 45 minutes. It is nature of the process. All of you using the same route. All of you are using the same bike. The person is in the same condition. Yes or no?
Yes, sir.
Suppose if someone is not reaching 45 minutes, he takes 85 minutes. What does it mean? What does it mean?
There is a variation.
Some problem.
That is not
some
in the control.
issues.
Is not in the control.
Process is
In the
not
acceptable.
as per the design.
Special cause impacted you.
Something new is happening. Something is affecting your process. Maybe his vehicle is punctured. We don't know. If vehicle is punctured, then it's a special cause. Do you want to adjust your process for the vehicle puncture and all? No, not required. Because it's a rare event. We all know, isn't it? It's a one-time event. So you don't have to worry. But if you want to be cautious, you can replace all puncture-proof tires. Somebody reaches the destination in just 20 minutes. What do you understand now?
Very fast. Control.
Uncontrolled.
He is so fast. There is a special reason for that particular person. Yes or no? Either he is so fast or he used a different route. Now reaching the destination so faster is a good result. Yes or no? See, special cause can be good. Special cause can be bad. Reaching late is bad, but reaching early is good. Now what will I do? I will learn from that person. Hey, how did you reach 20 minutes? Sir, I used a new route. Now I will ask everybody to follow the new route. Now, what will happen? Everybody will start traveling, reaching the destination in this place. My process has, come to a newer level. 20 is the process average. 25 is my upper control limit. 15 is... Do you understand? Earlier, my process was having a wider spread, but now my process has become a smaller spread. So you can learn from the variation. Variation, it can be good, variation can be bad. Bad means try to eliminate. Good means try to learn. Try to internalize the particular cause. Whatever is the reason, if that is good, try to internalize as part of your process. If you internalize good things as part of your process, we call it continual improvement. Your process will tend to improve. Yes or no? The control limits will start narrowing. So you need to basically understand whether the variation is due to a common cause or due to a special cause. If the variation is due to a special cause, what are you supposed to do? What are you supposed to do? You need to investigate. You need to investigate and you need to find out the root cause for the variation. And if the root cause is eliminatable, you please eliminate. Suppose sometimes if the special cause is favorable, then also you investigate. Find out the root cause, but make the root cause part of your process. Because it is producing good result, isn't it? Some of you score abnormally high marks. We can learn from you. Yes or no? Share that knowledge with other participants. As a result, our batch average will improve. Isn't it? So this is how you need to do. So now I take you to Minitab and see how can you select the control chart selection. Selection of control chart. It basically depends on data type. If your data type is continuous data, if your data type is continuous, then you have three charts. One is X bar R chart. Another one is X bar S chart. Then another one is IMR chart. I'll tell you what are these, and this is what we are going to see right now. And X bar means average. R means range. So this is also known as average range chart. Average range chart. And here it is average. S means standard deviation. Average standard deviation chart. And here IMR means individual moving range. So all the three charts, when can you use? When your data is
Continuous.
continuous or discrete?
Continuous.
Continuous.
Continue.
And now
Continuous.
within the three, how to select? If your sample size is less than 8, right? Less than or equal to 8. When to go for X bar S chart? When the sample size is more than 8, right? And when to go for your the IMR chart? When the sample size is equal to 1. See, sample size is a tricky subject. I mean, tricky topic. Always, is a debatable discussion. Sample size, please note, first of all, I want all of you to understand sample size is nothing but the subgroup size. Sample size is nothing but subgroup size. So what is a subgroup? Number of samples taken simultaneously. Yes or no? Number of samples taken simultaneously. Always hereafter, when you are collecting data, you have to decide about the spread of data collection. Right? Spread of data collection. How many days you want to collect the data? How many hours you want to collect the data? You should decide on that. And then number 2, frequency of sample collection. After deciding about the spread of data collection, frequency of data collection or sample collection, then only you must talk about sample size. All of you understand? If you go in this order, your sample size can be restricted to this number. What is the sample size you are seeing here? Sample size can be
2 to
2 to
25.
25.
2 to
Greater
25.
than
That's
equal
all.
to.
The lowest is 2 and the highest can be 25. In fact, 1 also possible. Let me put 1. 1 also possible. 1 to 25 is the sample size always. The sample size is nothing but the number of samples taken together. The number of samples taken together forms a group. We call it subgroup. So it is nothing but the subgroup size. We often call it as sample size. So now the subgroup size. So sample size means what? Subgroup size. Just understand how many samples you are actually picking. If you pick 8 less than 8, then what is the chart recommended? X bar,
X bar, R chart.
R chart. Where X bar is average, R is range. If
Average,
suppose
right.
you pick 10 samples at a time, now you have to go for
X bar,
X bar
X
S
bar,
chart.
S chart.
For some reason, let's say it is a destructive testing. You can't destruct everything. So your company wants you to pick only one sample. Now you have to go for IMR chart.
IMR.
Is the one more important condition? The variable of interest be a continuous variable. Tell me, if it is a diameter, is it continuous or discrete?
Discrete.
Diameter is discrete. Do you think
No.
diameter does not have any unit of measurement?
Yes,
Diameter
maybe
is the unit for diameter.
Measured.
meter,
Measure,
measurable,
direct.
meter.
Sir, it is
centimeter.
continuous.
Measurable. Continue.
It is continuous.
Length, coating thickness,
It will be micron.
right? So labor turnaround time of a process, cycle time of a process. These are all continuous variable. All right. Now once you understand the data is continuous, try to understand the subgroup size or sample size. And based on the sample size, your control chart will be 1 out of the 3. Now let me pick up a sample project data here. For that, I go to File, Open Worksheet. File, Open Worksheet. Then this window will come. I have to click here once. This is a sample data folder. I have to click here once. And then I must type camshaft here. Camshaft. Now this option I will choose. Camshaft.mtw. I just open it. Again, I give OK. And see, once I do that, I could see a data talking about length of the product. Can you see here, all of you?
Yes, yes.
How many data available?
100.
100.
I
100.
will tell you how the data was collected. The data collection plan I will reveal. The person who collected the data, he collected 5 at a time. So the first 5 constitute subgroup number 1. Do you understand? The next 5, after some period of time, maybe after 4 hours, he take another sample of 5. He take another sample of 5. So 6 to 10. What is this actually 6 to 10 called?
After
Group,
2 hours
subgroup
after
2.
sample
Group.
collection.
Very good.
Subgroup 2.
Subgroup 2.
Group
So what is
2.
the sample size in this case?
Subgroup.
Sample size. What is the sample size in this case?
5.
Every time
5, sir.
10, 10, 10, 10.
Next 5. 5 only.
Five.
Five. You totally have 100 samples, but 5 at a time. So 20 times you have taken sample. Can you see that?
Yes, yes.
Yes.
So number of subgroup is 20. Subgroup size, nothing but sample size is 5. And your data is continuous data because it is length. Now tell me which control chart I should plot.
Yes. Second, X bar and S chart.
R chart, X bar R chart. Average range chart.
X bar.
Beautiful. X bar R chart is the right option now. Let me show you how you can plot the X bar R chart. And already we
Okay.
understood that
All right.
we are AI enabled, right? So let us use Minitab. So no more graph sheet, no more scale pencil, right? Use this. So go to stat, go to control chart. You can see here. Now there is variable chart because we are dealing with variable, right? Variable chart for subgroup. Which option I should choose here? X bar or?
X bar R chart.
Can someone read
What
the
are the
description? Can someone read
What
the
are the
description?
mean and the variation? Range of your, that means range of your process when you have continuous data in subgroups works best with subgroup. Subgroup size of 8 or less.
Our understanding is in line with the description. So you
Yes,
click
the
that.
subgroup level is 5. So it
Very
is
good.
coming.
Very good. So click that and now all observation in one column. How have you organized your data? Your all data is available in column number 1. Yes or no? So
Yes,
our
sir.
data is organized in just one column. So remove all the old one. And now that column 1 is the data that talks about the length. Select. And now subgroup size. Tell me what is your understanding subgroup size?
5. 5.
Now,
Five.
now I want to understand whether this process is under control or not. Whether this process is under statistical control or not. I want to understand whether the process is experiencing only common cost variation or also special cost variation. You understand my language? My
Yes.
process experiencing common cost variation is expected. But my process experiencing special cost variation is unexpected. Yes or no? If
Yes.
unexpected things starts happening in your family, will you keep quiet?
No.
No.
You have to stand up. No, you have to go to the spot and try to understand. If some questions have to be raised, please raise those questions. Try to bring that situation under control, isn't it? So that the unexpected things will stop happening after your action. That you must take. So I declare this. So right now our understanding is special cause is nothing but observations going beyond the control limit. Yes or no? So
Yes.
first test for the control chart. I will choose here. I will go here, X bar R option. See here, test. So many tests you can check. Special cause, the test for special cause is point falling outside control limit. Control limit means beyond 3 standard deviation away from the center line. Can you see here number 3? That first
Mhm.
point alone I want to check. Perform the selected test. First test. See, you can put as many conditions as you want for your children. Yes or no? To grow them, well in the society. You can put as many conditions. But the first initial conditions will be very, easy to adopt. So easy to adopt condition is expecting all the points inside the control limit. That is the easiest test. First you apply that. Later on you can tighten your rules. You understand what I'm telling? This is how we control our children's also. So I'm applying only the first one. I'm saying okay. I'm giving one more okay. The job is done. Are you able to see the control chart here, all of you?
Yes.
Yes.
Yes, yes.
There are two control chart coming here. One is R chart, another one is X bar chart. R means range, the spread of my process. X bar means the focus of my process, the center of my process. Please understand, all of you, the range is a value of the spread within each subgroup. Do you understand? Range is the spread within each subgroup. Each subgroup, how many samples you have? 5.
5.
Within the 5, there is a maximum, there is a minimum, isn't it? The difference between maximum to minimum is calculated and it is getting monitored. Why? Randomly, if you pick 5 from a same process, all 5 must be close to each other. Then only consistency is possible. Consistency in the quality is possible. If all 5 are equal to each other, then the range should be small. If the range is not small, if it suddenly becomes bigger, it's an out of control scenario, right? So we monitor the spread. I am happy by seeing that all the range values for all the subgroups are under control. All of you, do you understand what is happening?
Yes.
See, yes, a subgroup containing 5 samples is selected every 4 hours. And the range is found to be under control. It's a confirmation that the 4 hours production is going in a smooth, consistent manner. Am I right? You are happy with the production for the 4 hours. Suddenly, if the range goes, outside the control limit, then something went wrong within the 4 hours. All the units produced within the 4 hours becomes objectionable. Do you understand, all of you? This is, this is how you must use the range data. The range means variation within subgroup. Variation within subgroup. Our expectation is range should be minimum. Once this is happening, once range is under control, you can start referring the X bar. You know what is X bar? What is happening in the first 4 hours? What is happening in the next 4 hours? What is happening in the third 4 hour? That is also important, yes or no? See, the shift manager will just look at what is happening within the shift, but the plant manager has to look at what is happening throughout the day, yes or no?
Yes.
In order to understand whether we are, everything happening throughout the day is also good, you must compare the subgroup average of the first shift with the subgroup average of the second shift. What is your expectation? The quality level you achieved in shift number 1 and shift number 2 should be the same, yes or no? This is called variation between the subgroup. If the averages are close to each other, variation between the subgroup is under control. You understand? There are 2 variation I'm talking about. Variation within subgroup, variation between subgroup. Look here, first shift went on well, second shift, all is good. Similarly, it goes. But 9th shift, can you see here what happened?
Variation is very high.
The average is shifted downwards.
Downward.
Now, how will you approach this scenario? If this happens in your process, in your variable, will you keep quiet, first of all?
No.
Then what will you do?
Investigate further.
Identify.
Yes.
Try to identify the issues
Right to
which
identify.
happened during 9th hour.
Very good. First of all, you understand there is a problem in the shift number 9. Shift number 9, how many units you might have produced? Let's say 5,000 units. This 5,000 units first you must quarantine. Yes or no? You
Exactly.
should not allow the 5,000 to get dispatched. Because if it gets dispatched, there is a possibility of too many complaints populating. Yes or no? So you must first of all prevent that. So quarantine you have to do. Meanwhile, the process should be stopped. Agree? But we may not be practicing all of this. I'm just talking, the scientifically, theoretically. But then in reality, many people know by seeing just one point falling outside, they may not be very serious. Yes or no? Because for them it is one point, but we all as a statistician, we all as a Six Sigma belt, we know this point is an average of 5 samples. It's not 1 point, isn't it? It's an average of 5
Right.
strategically taken sample. Average of strategically taken 5 samples. Sample average. The 5 can be a very good representative of 5,000. Yes or no?
Exactly.
If 5 is wrong, all 5,000, no, majority of the 5,000 can be wrong. If the majority of the 5,000 can be wrong, you don't make any changes, continue the process as it is. What will be the quality of next 5,000? Is it
Similar.
affordable? Is that risk bearable? Think
No.
about it.
No.
If the answer is no, you must stop the process. You must stop the process and then investigate. Yes or no?
Yes.
Go to the spot, we call it Gemba, and then try to collect some information like an FIR, police, how they are doing. They go to the spot, isn't it? Any problem happens. You also should go to the spot and collect as much information as possible, take photographs, note down the settings, note down the operators involved, note down the supervisor involved, come with all the data. Later on, that can help you. Yes or no? Later on, that can help you to find out the root cause. Once the root cause is found, and you ask yourself whether the root cause can be a recurring root cause or is it just a one-time root cause. If some setting is unintentionally changed, what kind of root cause it is? Tell me. Some setting was wrongly set by the operator. What kind of root cause it is? Is it a one-time root cause or a recurring root cause?
One time, maybe
So
one
one time.
So correct it and then allow the process to continue. But if the root cause you can't predict or you understand it is recurring means it's not a human error. It is a process error. You must study the process, try to find out what is going wrong, whether the machine itself, is changing the setting, In that case, fixing the root cause is challenging. So you have to act accordingly. Once you fix the root cause properly, then you allow the process to continue. All of you understand here
Exactly.
how the control chart is helping us. Control chart helps you to understand the questioning opportunity, investigation opportunity. It is an investigation opportunity. If there is an opportunity for investigation and you don't investigate, something big can go wrong later on. Yes or no? Like our body is sometimes giving strong signals. We immediately apply leave. Yes or no? We don't go to office. No, just like that. So same manner, some rest is required for your process. And you should also think about what went wrong. Oh, yesterday I took the wrong food and I'm not going to take it anymore. So just one day rest will do and then I'll go to office. But if I am not able to figure out the reason for my headache, then what should I do? I should go to the doctor. Yes or no? And it continues, isn't it? The headache continues for 1 day, 2 day, 3rd day, and 4th day also. Now I will go to the hospital. Same approach is required. Whenever there is a questioning opportunity, you must question. Whenever an investigation opportunity, you must investigate. If you don't investigate, the problem will come, again come with a higher magnitude, which will definitely be unbearable. All right. This is how control chart must be used. And if the subgroup size changes to 10, then we go to X bar S chart. If subgroup size changes to just 1, then we go to IMR chart. And with the same data, just to demonstrate, I will show you how the other charts will come. See here, a variable chart for subgroup.
Sorry,
I
sir.
go to
Sir, that
yes.
I'm a chat. Can you tell that? If it
Yeah,
is above.
I'll come to that. I'll come to that. Now X bar S. X bar S situation will be same. Only difference is subgroup size will be more than 8. Now it's an assumption, not matching with the data. Let me choose the same data. It's only an assumption that subgroup size is 10. Control chart testing. You all know we have selected only one test, only one. See, there are multiple tests possible. I'll teach you a little later. So give okay and one more okay. And now see here. This is an illustration of X bar S chart. Please note, this is a wrong practice what I am demonstrating. Data is collected with the subgroup size of how much?
5.
You are not supposed to combine
Now
two
it
subgroups
is
and say that no subgroups existent. That's a wrong practice. Do you understand? Clubbing two subgroup doesn't mean subgroups existent, but I am only showing it only to teach you Minitab, no other purpose.
right.
And since you asked IMR chart means only one data is possible. Right? Only one data is possible. Like, for example, daily sales. Daily sales, how many data you get every day? Only one data, isn't it?
How much sale we did?
So if what is your expectation with respect to your sales? Sales should be, around the target value, isn't it? Around the expected value. If the sales is around the expected value, can your sale differ from the previous day sale?
Yes.
If your sale is, more or less same, then yesterday's sales and today's sales will be close to each other. If you calculate a range between your today's sales and yesterday's sales, this is called a moving range. This is called moving range. The moving range, if it is minimum under control, your sales team is performing well. Your sales team is performing as per the expectation. Suddenly, the moving range is abnormally high. That means there is a special cause. So suddenly sales has gone up. An offer was announced. Right? And people, buy more. Suddenly sales can drop. If sales suddenly goes up, suddenly comes down, it's a questioning opportunity for you, isn't it? And try to understand why the sales has gone up. Also try to understand why the sales has gone down. Ask yourself, is it a one time or a recurring? If it is one time, try to fix and then don't bother. But if it's a recurring, yes, you have to find out the root cause scientifically. And now let me also show you how the IMR chart will look like here. For that, you have to go to control chart and choose variable chart for individual. And then you have an IMR. You click that. See here, the way I'm doing here is not correct because I simply change my, data. I'm using,
Size.
according to my requirement. But in real time, if the subgroup size is 1, then only you should plot. Right? This is only illustration. So the length, go to IMR option and again test. Only one test. Okay. And this is how the IMR chart will look like. Are you happy with the length of your product? The moving range and the average. Seems to be under control. You see here. Seems to be under control. But here, what is wrong? My way of sample collection is wrong. I have taken 5, but here I am feeding as 1. I am theoretically wrong. So never be theoretically wrong. Never violate any principle. Then what will happen? Your analysis will become a garbage in, garbage out analysis. Right? This is only, I'm using it only to demonstrate how can you plot IMR chart in Minitab. Just go to stat, go to control chart. Now here you have the X bar R and X bar S. Here you have IMR. So this is about my control chart. All this knowledge about how to plot a control chart, which variable to monitor, how many sample size, frequency of sample, and duration of sample collection, all the knowledge you gained, if you make it as a document and pass it to your team member, that complete set of document is known as control plan. As long as your team follows the control plan, your process will continue delivering the results as expected. You can go for a vacation. Nothing wrong will happen. Right? So what will happen in the improve phase? What will happen in the control phase is, can be understood well with the use of the analysis tools and control chart. Yes or no? If the tools are learned properly, then improve phase and control phase is an easy to understand theory. And then implementation also will be very realistic. But if you are weak in the tools, the analysis tools, as well as the QC tools and other things, then all your brainstorming sessions will be very vague. All your meetings can also be vague. Just imagine you have all this useful piece of information in your table, and a set of 10 green bells sitting in front of you with the same level of competency. How fruitful the discussion can be. Do you want to create such a scenario for your company? Then we have a good opportunity for all of you. All of you, those of you who said yes, you are expected to nominate at least 5 people from your company for our next batch. Right? Our next
Definitely,
batch.
sir.
is- our
Because
next batch is
actually,
coming.
no, for that actually, I'm planning to take my colleague, but unfortunately, he's
Yeah.
not joined.
So next month, second Saturday, we are starting our next Green Belt batch. And within June, 29th of June, we are starting our evening batch. And we do have another fantastic program known as Lean Champion, where we give more focus on lean. So lean is all about enhancing your efficiency so that your operating cost can go down. You enhance your efficiency and reduce your operating cost, but not compromising your standards and quality. So lean tools are also equally effective. So there will be more exposure on the lean tools in the Lean Champion, and we have a batch commencing in the month of July. First week of July, it's a 2 days program fully focusing on lean. So depending on your organization requirement, you can nominate people for our Lean Champion course or Green Belt course or the Black Belt course.
Online or offline, sir?
Online, every month we have plenty of options in online. But when it comes to offline, in Chennai, we have the classroom batch commencing alternate months. Similarly, in other cities, for other cities, the dates will be announced soon. Right now, we are doing only in Chennai. We are planning to do it in Jaipur because we have Vivek Kumar sir, from Jaipur coordinating our activities. In Bangalore, programs are coming up. Hyderabad, and then Delhi and Mumbai. So these are certain cities where we'll be announcing the dates, and then you people can utilize. But online, of course, wherever you are, you can nominate.
Sir, in your organization, the chartered quality manager is course is the TQM.
You want to learn TQM? Yes, that we can do it as an in-house program, because once you become a Six Sigma belt, you are expected to have a proper clarity. See, everything is same. First of all, please understand. Ultimately, what do we want? We want quality, we want productivity, and we finally want to make money. Whether you follow TQM or you follow Six Sigma or you follow Lean, that has to happen, right? The terminology slightly differ. The principles remain same. All the principles you are learning in TQM, the principles, they use a different language, but finally all of them will focus on customer satisfaction. We
Sir,
can
company-oட
we can
vision
train
என்னன்னா
your
sir?
people on TQM also, right? In a fantastically as an in-house program. But if there is a good demand, we can offer it. We can make it as a public program.
சார் அந்த செகண்ட் திங் எனக்கு அந்த காமன் காஸ்ட் வேரியேஷன் சொன்னீங்க இல்லையா அந்த வேரியேஷன் அக்கர் இன்ஹரண்ட் நேச்சுரல் அதுக்கப்புறம் எனக்கு அதை
Inherent
விட்டு
of the process. The nature, based on the nature of the process, certain variations you have to live with. That will anyway will come.
ஓகே சார் அதே மாதிரி ஸ்பெஷல் காஸ்ட் இது வந்து இன்வெஸ்டிகேட் அண்ட் ஃபைண்ட் அவுட் த
Special cost variation means something went wrong in your process. Then only that will happen. You can easily fix special cost variation. But if you have a requirement to fix common cost, then you have to think about redesigning the process. It's not that easy. You have to redesign, look into the fundamentals, and make the necessary changes. Then you can even fix the common cost. Nothing wrong. But some amount of common cost, even after improvement, will exist. Always it will exist. Because God has created the world in such a manner. You have to adjust with him. You can't eliminate problems completely. You should live with little problem. All right. Okay. So all good. Shall we proceed for the lunch. So Vivek Kumar sir, you want to say something? Or shall we go for lunch?
Yeah,
RK sir?
we can go for the lunch. Whatever you just told, I just want to add one thing, that this particular program, when we are giving the certification in Lean, which is Lean Champion, is something very unique, because typically in industry, certifications are in Lean are less common.
Yes, yes.
So if you have a certification that you are able to show to your prospective employers and prospective clients, it gives you a lot of credibility.
See, there are many, many success stories we have been hearing. And it all depends on how you take up the matter. If you take it very seriously, and you will start seeing, fantastic results. Our last batch black belt, and a candidate got, already is in a senior level position. He got a new job with a designation of Director Supplier Quality in a company, Alstom in Bangalore, and with 70% hike in the salary. He's extremely happy, and he in fact mentioned in the review. I think that video also will release. So the interview had 10 rounds. So he clearly, he could feel, the level of confidence with which he, answered all the questions. It is basically because of his level of confidence and the sharpness in questioning and answering. He was selected. He was given the opportunity. So we are also extremely happy, hearing such a feedback from one of our participants. That too, senior level person. Right at the time of receiving the certificate, he confirmed that. Such results can happen for each one of you also. So take it very seriously, and then, put more effort. Don't just, participate for the sake of certificate. Participate for the sake of succeeding in your career. Definitely it will happen. All right, all the best. So we will stop here for our lunch. And 2:15, all of you are expected back. Hope it is okay with all of you, right? 2:15, we will be starting up.
Please share the champions.